Hello, we are Stephen Scheuerle and Alberto Quiroga. We worked on the Mars Atmosphere and Volatile Evolution mission, also known as the MAVEN.
In this presentation, we're going to go over the overall objectives of MAVEN, some of the scientific instruments that are attached to MAVEN, the orbital maneuvers that got MAVEN in place, the solar wind ion analyzer, which is a specific instrument that is attached to MAVEN, and an overall mission summary.
In the first starting process of the MAVEN, they wanted four objectives for it to have. First, it wanted to measure basically all of Mars' atmosphere. How has it played through time and how has it evolved? Another thing is that we wanted to see the upper atmosphere, the ionosphere, and interactions it has with the solar wind. We also wanted to know about the escape of neutral gases, whether it stays intact or it does escape the atmosphere, and the ratios of stable isotopes in the Martian atmosphere.
Some of the scientific instruments that were attached to the MAVEN spacecraft included in three packages: the particles and field packages, the remote sensing package, and the neutral gas and ion mass spectrometer. The particles and field packages consisted of a solar wind electron analyzer, a solar wind ion analyzer, a superthermal and thermal ion composition, a solar energetic particle, a Langmuir probe and waves, and the magnetometer. Inside the remote sensing package included an imaging ultraviolet spectrograph, and in the neutral gas and ion mass spectrometer, it was an instrument all in itself.
To go more into detail about the different packages in the MAVEN, we first look at the particles and field packages. This characterizes the solar wind and ionosphere of Mars. Another package is the remote sensing package. This determines global characteristics of the upper atmosphere and ionosphere in Mars. Lastly, the neutral gas and ion mass spectrometer measures the composition and isotopes of neutral ions.
There were 6 orbital maneuvers that had to get the MAVEN spacecraft into placement. The first was the launch. The launch consisted of an Atlas V rocket. The cruise all in itself had a Centaur upper stage that got it into trajectory to get to Mars. The Mars orbit insertion slowed down the MAVEN spacecraft so it could enter orbit around Mars. The transition phase got it orbit close enough to the atmosphere to conduct experiments. Then in the primary science phase, it was able to conduct experiments for a year, currently which it's in, and the extended science and relay stage increased the orbit of the MAVEN spacecraft so that it can act as a relay satellite for future Martian missions.
In the solar wind ion analyzer, we see it measures the flow of solar wind energy through the Martian magnetosphere. It also determines the ionization rates of neutral hydrogen prior to being ionized from charge exchange.
Overall, MAVEN was able to meet or reach all of the goals that it set out to do. It has been able to explain a lot of aspects in regards to the ionosphere and the magnetosphere of Mars. Thank you for watching and learning more about the MAVEN spacecraft.